Hey, Mr. Allred here, and we're going to rationalize some denominators with some practice problems. I got 3 of them here. The first one is A, which is the fraction 9 over the square root of 5. And remember, when we say rationalize the denominator, that means we're trying to get rid of the root in the denominator. So if there is a root, we're going to multiply it by a root that will help cancel it out. So square root of 5, square root means I'm looking for pairs, and there's one 5 under there, so I can multiply by itself. So square root of 5 times square root of 5 will give me square root of 25, which is just 5 in that denominator. Now, if I'm going to multiply a fraction by something and not change the value, I got to multiply by the same thing on top and bottom. So I have to multiply the 9 on top by square root of 5 as well. And there's not much that happens up there. It's just 9 times square root of 5, and that would be all over 5 in the end. So I have the same numeric value, but without the root in the denominator. 9 square roots of 5 over 5. B, my second example, is 2 over the square root of 7x. So, once again, square root means I'm looking for pairs of things. So on the bottom right now, there's a single 7 and a single x under the square root. So I'm going to multiply by the same thing, square root of 7x. And what that's going to do is on the bottom, give me square root of 49x squared. But I know the square root of 49 is 7, and I know the square root of x squared will be the absolute value of x. So I've gotten rid of the root on the bottom. I have to multiply by the same thing on top, so 2 times the square root of 7x doesn't change. It's just 2 times the square root of 7x. So a lot of times if we rationalize something, we will get rid of the root in one place, but it'll show up in another usually. So the final answer there, 2 times the square root of 7x all over 7 times the absolute value of x. And those 7's can't reduce because one of them is the square root of 7 and one of them is 7. Okay, part C, the last one here, is 3 over the cube root of 2x. So remember, a cube root means I need to have 3 like things for it to work. So I have a single 2, so I need 2 2's under there, which I could write as 4. And I have a single x, so I need 2 more x's, so I need an x squared. So I'm going to multiply the bottom by the cube root of 4x squared. Bringing that over, you can either leave it as 3 2's here, or you can write it as 8. Doesn't really matter. And then you have an x cubed, but since it's the cube root, okay, keep that in mind. That didn't work out. There we go. Since it's the cube root, we have to multiply by a cube root to be able to combine them. And we also have to have 3 things. So right now, I do have those 3 things. Let's see if my pen is catching up with me. Yes, it is. So on the bottom, 3 2's, they'll come out as a single 2. There's 3 x's to the x cubed, they'll come out as a single x. So I have to multiply by the same thing on top, which is basically 4x squared, the cube root of that. That's just going to come over as 3 times the cube root of 4x squared on top. So once again, that 4 and that x squared on top is under a root, so it doesn't work with the 2x on the bottom, so you can't cancel anything out there. So my final answer, 3 times the cube root, I clicked on the wrong pen there, 3 times the cube root of 4x squared all over 2x. Thank you.